Okay, and in this one, we looked at sample number 5, which was left open to the atmosphere. In other words, if the CO2 was produced or whatever kind of gases that were going to be produced during the fermentation process, they were just going to be allowed to evolve naturally and not retained in the composition. And so again, using a twofold dilution, the top fluid gave a light reading anywhere between 20 and 40 mg per deciliter, with a little bit more emphasis on the 20 mg per deciliter, so definitely not as concentrated in that topmost fluid, which you see there. Again, that is the diluted version on the left relative to the right. And again, using the twofold dilution with that concentrated composition at the bottom of the vial that collected, you have the undiluted on the right, the twofold dilution on the left, and here is the alcohol that was detected with this test strip. And so you can see that it also lies at least at the 40 mg per deciliter marker, but probably a little bit more than that. And this would be the result then of the open air environment. So it's important to realize that the alcohol does dominate within that concentrated region. If I may just show, again, this is a sample number 3 bottle, but in that bottom part there, where my finger's tapping on the glass at the bottom, you can see, and it's kind of like that pinkish purplish mess, that's where the action is, and that's where the liqueur is then generated. And obviously it's going to collect within that yeast, and it's going to be a bit more pronounced as shown in these detection methods. So even if there is liquid sitting on the surface, that will still have limited but marked benefits of being able to retain the fermented product actually within that material.